So in this chapter, we'll describe the characteristics of solid states. We'll try to distinguish between amorphous and crystalline solids. We'll learn about them, what are amorphous and crystalline solids. We'll classify crystalline solids on the basis of nature of binding force. We'll not discuss much about the amorphous solids. We'll go deep into it and we'll define the crystal lattice and its unit cells. And we'll also explain the packing, the closed packing of the particles in the crystal lattice. And in the crystal lattice, when you do packing, there are some space left. We'll discuss the space, that is the voids in the packed structure. And we'll also discuss the efficiency of the packing of different type of cubic unit cells. You'll just understand all these terms when we go through the chapter. We'll also discuss and correlate the density of substance when you discuss the density with respect to the unit cell, because in our chapter we'll be more focusing on the unit cells. These unit cells, right? How they are packed, what is the packing efficiency, what is the efficiency, what is the density, what are the different types of unit cells, right? And what is the binding force in the unit cells. So we will focus more on the unit cells, right? We'll also discuss the imperfections, the impurities in the unit cells, actually in the solids, but actually it is the unit cells, the imperfection there. And we'll also correlate the electrical and magnetic properties of the solids in the structure. So we'll discuss all these things. We'll start with the first main difference between the solids, amorphous and crystalline. We'll pick this crystalline and then we'll start with the unit cells, how it is packed, the efficiency of the unit cells, the density of unit cells and stuff like that. And then also talk about the electrical and magnetic properties of the solids. So if you see, there are three states of matter: solid, liquid and gas, right? So for example, this is H2O in the form of ice, is solid. In the water, this is liquid. And in the form of vapors, it is gas. So a matter can exist in three forms. Like if you see, in this case, the same matter exists in three forms, and the only difference is temperature. You keep heating, solid becomes liquid. You keep heating, liquid becomes gas. So based on the temperature and pressures, a matter can exist in the various phases. And if you see, the most of things we see around us is solid. Correct? And they have different application based on their properties. And these properties actually, if you see, are dependent on the nature of the constituent particles which are made of. For example, this is made of hydrogen and water, and the force binding them. Correct? You'll see different metals or different solids. You have something like iron, and if you compare plastic or if you can compare glass, don't you think all are solid but they have different properties? This guy is conductor of electricity. These two are non-conductor. This iron is very hard. Plastic is little soft. Glass is brittle. So if you see, if you compare most of the solids, now I'm focusing only on solids, they have different properties. And why they have different properties, we'll discuss that. The difference in properties is because of the constituent particles which they have, because each of these have different constituent particles, and also the binding force that operates between these constituent particles are different, right? And that's why the study of solid is very, very important to us, right? Because most of the things we see around us is solid. If you talk about the car, bus, everything is solid. Correct? Also, if you know the various properties of solids, and not only the properties, if you know the reasons why glass has XYZ property, plastic has some unique properties, iron has some unique property, why these has this unique property, then you can discover and invent also new different solids which has some desirable properties. For example, you want something, I can take example of graphite. You want a lubricant which should work at very high temperature. Normal lubricants, if you see, it burns at high temperature, but you want a lubricant which will work at very high temperature. Then with the property, we see that graphite is a good example. You want something to be very hard, you use diamonds. You want to create super high computers, right? So in that case, you will see in this chapter itself that we create transistors by doping silicons, N-type, P-type, and with that we make various transistors. You want to make super high transistors. Then based on the various properties, based on the of these silicons and the doping elements, we create super high conductors. We want to create very good quality magnetic materials, and it's good to understand why a substance is magnetic, and then we can make good magnetic materials. If you want to make biodegradable polymers, because now if you see all the plastics, the normal plastics are non-biodegradable and it is causing environment pollution. So there's a demand for a biodegradable plastic. So it is, since if you know the properties, you know the basic building of a particular solid and why they behave in particular way, then you can actually create biodegradable plastics also, right? Also you want for example surgery also, you want some material solids. So in that case, for surgical implants also, you can create different kind of material just by knowing these properties, right? Because we know that these has different properties. You want to go to deep root and understand at the unit levels, atom levels, and the cells level why it is behaving in this fashion, then we can actually create other solids with desirable properties, correct? And that's the main reason why we are studying this chapter, because we see solids around us and we want to understand it deep, all the properties and why it is, so that we can create new solid materials with desirable properties, correct? So if you see, this is a good example of solid in our day-to-day life. You see the guns we use, not we the police people, I mean, it has different properties. It has to be hard. The soap we use, again, this is also solid, but they are different, right? The eraser which we use, again, solid, but they have different purpose. If you see the plastics and the metals in the clocks, all solid. The vegetables we use, they are also solid. They are biodegradable. If you see the cans we use, it has tin. The pastry cakes we use, it is also solid. But if you see it's spongy. The kettle, the pens, the sword, and this magnets. If you see, again, the solid, it has a different property, right? It's magnetic. The coins which you use, it's shiny. The chalk which we use in the classroom, that is also solid but has different property, right? It writes on the board. The diamond, it shines. It's very good for jewelry. These nails, very strong, right? And the computers, if you see, computers has a microprocessors, and these processors are made of transistors, right? And these transistors are nothing but silicon which is doped. You create N-type and P-type transistor. We'll discuss about these. These are nothing but solids. And this wood is again a solid. The car, if you see, the whole car is made of solids. This pen is also solid. So if you see things around us, so many things we use. This bottle, this glass bottle is also solid. It has a different property. Most of the modern medicines, if you see, this is in the glass, or the pickle, we use a glass container to store. It has different property. The plastic bottle, if you see, again is solid. But each of these solids you think has a different property. Some are very hard, right? Some easily dissolves in water. Some is used to clean things or erase things. Some are biodegradable, right? Some are transistor. They have a unique property. This is magnetic. This is spongy. So I mean, we use different kind of solids in life and with different properties, and that is a very valid reason why we should know the solid state chapter, right? How these and why these particles have different properties. What is the main reason why this cake is sponge but the gun is hard? Why this carrot is biodegradable but chalk is not? So why this processes have a different property, how it works. So why this magnet is magnetic. So all these questions can be answered if you know this chapter very well. So since we'll be focusing only on the solid states in this chapter, let's discuss some of the properties of the solid states. These are some solids which we use in the day-to-day life. Some of the properties of solid states, if you have observed by this slide, is they have definite mass and volume. So if you keep the gun anywhere, it will have definite mass. The diamond, the magnet, they have different mass, they have different volume, they have different shape. If you keep a glass of water, the water will have definite mass, volume, but the shape will be different, right? I mean, if you put in another container, the shape will change. If you talk about gas, their volume is also not constant, right? It all depends on the container where you pack it. But solid has definite mass, definite volume, and definite shape. But liquids and gas, they don't have all these value definite. They have the intermolecular distance between them is short. So when I say intermolecular distance, for example, I have, let's say, sodium chloride. So I have sodium and this chlorine ion. This distance is very, very small. Since the distance is small, right, the bond is strong. The bond is strong and it has definite mass, volume and shape. Correct? See, this has definite mass, volume and shape. That is something easy to observe. But why? Even a layman can say, okay, this has a different mass, volume and shape. But as a chemistry students, the next question is, why do they have definite mass, volume and shape? So the answer should be, these constant particles of the solids, the intermolecular distance between them is short, and thus the intermolecular force is very strong. Both are actually same point. Since the intermolecular distance is strong, the intermolecular force is strong, right? Distance is short, force is strong. Since the force is strong, I mean, it is difficult to break this. If it is difficult to break, it is more strong, it is more sturdy, right? And their constituent particles are in a fixed position. They have fixed position and they can only oscillate about their mean position. We will talk about these when we talk about the actual structure, interior structure of the solids. So if you see, this is, if I have some crystals like this or any solid like this, these are the constituent particles. So they are almost fixed in their position. They are not allowed to move, but they can only vibrate. They can only vibrate about their or oscillate about their mean position. They can oscillate in this direction, they can oscillate in this direction or in this direction. They can just oscillate, but they actually can't move from here to here. They're almost fixed because the distance is short and the intermolecular force between them is pretty strong. So they are all tied up. They are like a big family. Everybody is tied up like a big network. We'll discuss about this in the next 2 slides when we discuss about the actual structure. I'm just assuming they are the constituent particles. And please note, in this whole chapter, when I say constituent particles, I mean atoms, molecules, or ions. For example, in NaCl case, we have Na plus ions and Cl minus ions. Right? In case of chlorine, for example, I have only chlorine atoms. Right? We'll see also case where we have molecules. So the constituent particles can be, I mean, if you see this chlorine again is linked to another chlorine, so there is again a force between these two. So in that case, when you talk about force between these two chlorine molecules, we'll say constituent particle is my molecule. When I talk about the force between these two chlorine, then I'm talking about the constituent particles in the atoms. It all depends what kind of level you are looking at, right? So at this point, these are my molecules, sorry, atoms, but this whole thing is my molecule. So these are my properties of solid state. They have definite mass, volume and shape. And why they have? Because the intermolecular distance is short and the intermolecular force are strong. And the constituent particles, that is the atom molecules or ions, they have fixed position and they can just oscillate about their mean position. Right? And they are incompressible and rigid. If you press this magnet hard with your hands, you'll see that you'll not be able to press. Again, why? Same thing, because they are all sturdy, they are very strong.